Hello 3D printing friends. Today on the BV3D channel we're going to design the desktop trash can in Tinkercad and then print it out in Vase Mode. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about cool 3D printer upgrades, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're going to design a desktop trash can in Tinkercad. Now, why would you want a desktop trash can? Well, for me, the answer is that the floor trash can here at the BV3D channel never seems to be in a convenient location. And that's especially true when I'm sitting here removing supports from a model, breaking a bit of support material off and then spinning around in the chair to throw it away and spinning back. It really isn't all that fun. But if I don't do that, then all that debris builds up on the desktop. So a small printed trash can is actually a useful thing to have on the desk. It's also a useful thing to keep next to your 3D printer. You can use it to throw away the little bits of filament that you snip off the ends of a spool when you're loading your printer, as well as the little priming lines and skirts that get printed around your parts. When it gets full, you can go empty it out into a regular trash can. It helps keep the area around your printer neat and tidy. Oh, if you actually have a way to recycle your filament, then obviously save it for recycling instead of sending it to a landfill. I'm using the term throw it away euphemistically. I also mentioned that we're going to print this in Vase Mode. Now, if you don't know what Vase Mode is, that's okay. For a long time, I didn't know what it was either. Some slicers call it Vase Mode. Some get a little wordier and call it Spiral Vase Mode, which is starting to hint at what it does. And others call it Spiralized Outer Contour, which gives us probably the best three-word description of this printing process. So what are the slicers trying to tell us about this method of printing? What does it mean to spiralize the outer contour of a printed model? Well, think of a slinky spring toy. When you see it in its natural compressed state, it looks an awful lot like a 3D print with layer lines, but you know it's not a stack of concentric rings. It's one single piece of metal. When you lift it up from the top, you can see that it's a spiral. In the same way, something printed in Vase Mode is also a spiral. When you slice a model for Vase Mode printing, the printer will print the bottom layers, however many of them that you specified, in the regular way, one layer at a time. But after that, it starts to move in a spiral pattern around the outer contour of the model, hence the term spiralized outer contour. As the printer traces the outer contour of the model, it is slowly and continually raising the z-axis. When the nozzle completes one orbit around the model, the z-axis has moved up your specified layer height. So when you print with a layer height of 0.2 millimeters, every time the nozzle comes around again, it is 0.2 millimeters higher than it was the last time it passed that point. In effect, it's creating a spiral, just like the Slinky toy. There are three things to note about models designed for Vase Mode printing. The first thing is that the path around the model has to be unbroken. For example, if you had a two-headed vase, the extruder would have to stop pushing plastic on one part, move to another location, and start printing again, and that wouldn't work. The second thing is that because the printer is moving the nozzle in a spiral pattern and always moving up, Vase Mode prints are only one perimeter thick. In your slicer, you have some degree of control over the actual thickness of that perimeter. Increasing the flow rate, for example, will result in a little more plastic being pushed out, which will thicken it up a bit. And the third thing is that models designed for Vase Mode printing are solid. They're not hollow. They don't need to be, because the printer is only going to print the outer wall. So knowing that the model is solid makes it easier for us to design our trash can because we don't have to worry about hollowing anything out. So this should actually be pretty easy. Let's get into Tinkercad and get started. Okay, so here is a new blank design in Tinkercad that we can play around in. But let's rename this because it is not a cool cup woof. It's a desktop trash can. There we go. All right, now let's think for a minute about the shape of a trash can. Many of them aren't really cylindrical. They're more of a truncated cone. There's a circular base and then a slightly larger circular top. Tinkercad's cone object allows us to set a radius for the upper and the lower parts, so we'll use that. Let's drag a cone out onto the workplane. I think having a little trash can about 100 millimeters tall on my desk would be just about the right size. So we'll set the height to 100 millimeters. Then let's set the base radius to 35 millimeters and the top radius to 45 millimeters. And we'll set the number of sides to 64 so that this is as smooth as Tinkercad can possibly make it. And that's it, we're done. Just kidding. Now you could certainly use this as it is right now and it would print just fine in Vase Mode. Remember, Vase Mode models are solid objects. But I think we can dress this up a little bit and make it look more like a classic Oscar the Grouch kind of trash can, which is what I had in mind. So you know how those trash cans look like a Greek column with the grooves cut in them running from top to bottom? We're going to make a part to cut that kind of shape out of this trash can. And the kind of shape that would make a cut like that is a capsule shape, essentially a cylinder with a half sphere on either end. And we'll make one of those now. So we'll drag a cylinder out onto the work plane. We'll set its number of sides to 64 so we get it as smooth as we can. Then we'll set its footprint to be about 15 millimeters by 15 millimeters. And we'll set its height to 70 millimeters. Now we need a half sphere object. And to make it easier to get it right at the top of the cylinder, I'm going to show you a trick. Did you know that you could move the work plane? If you've ever wondered what this work plane item here is, that's how you do it. We'll drag that work plane out and put it on top of the cylinder like this. Now the work plane is where we need it for this next operation, and we don't have to fiddle too much with object placement. Let's drag a half sphere out onto the top of our cylinder. We'll set its footprint to 15 millimeters by 15 millimeters. And we'll set its height to 7.5 millimeters, which is half of 15. We're just trying to keep its proportions. Now draw a selection around both the cylinder and the half sphere. And then we're going to use the alignment tool to align their centers. And then we'll click away from it. Now, due to a teeny tiny inaccuracy in Tinkercad, we need to embed this half sphere just a little tiny bit into the cylinder. And if we don't do this now, we'll have trouble later. So to do that, with the half sphere selected, click and drag a little bit on the cone-shaped handle that lets you move the object on the Z-axis. What we want to do is set it to be negative 0.1 millimeters, and that will drop it just a tiny, tiny bit into the cylinder. And with that done, we can draw a selection around both of those and then group them together. Let's reset the work plane back to its usual location. Drag a work plane out onto nothing so that it resets the work plane. Now we need to flip this cylinder and repeat the process of adding a half sphere to it. So click the cylinder to select it, and then click here to set the angle and set it to 180 degrees. Now that it's upside down, we can drag another work plane on it. And we'll repeat the process of adding a half sphere, setting its size to 15 millimeters by 15 millimeters by 7.5 millimeters, selecting these and aligning them, and dropping the half sphere just a tiny bit into the column. Then we'll group those together and reset the work plane. Okay, so now we have the body of the trash can, which is a truncated cone, and we have a capsule shape that we'll use as a cutting tool. Let's align the capsule and the trash can a little bit because I need to show you something. Let's switch over to a top view. Oh, and while this perspective view is cool, we need to use Orthographic View to get a better idea of how things are lining up. So click right here to turn on Orthographic View. Okay, let's draw a selection around both the trash can body and the capsule, and then we'll align them. Just on that one center. Now we'll switch to the front view so I can show you something. Notice the angle on the side of the trash can? If we move the capsule over to the left, we can see that it's not going to cut evenly when we turn it into a whole part. We want to set the angle of the capsule to match the angle of the side of the trash can so it'll cut evenly. For most non-precision designs, and this is a non-precision design, you can use your eyeballs and the TLAR method. What's TLAR? It stands for that looks about right, and it involves adjusting things until you're satisfied and say, well, that looks about right. For this design, I already did the hard work, by which I mean I used trigonometry to figure out that the desired angle is 5.71 degrees. But let's do this by eye and see how close we can get it. So we'll adjust this using the angle setter here. And yeah, 6 degrees. That looks about right. See, TLAR, it's a thing. Okay, now let's use the alignment tool to center the capsule within the height of the trash can. So we'll select both objects, use the alignment tool, and align them on center here. Let's maybe nudge that over just a bit, and we'll take a look at this. We'll turn the capsule into a whole part, I want to look a little bit more closely at this. And that looks like it's going to cut about the amount that I want cut out of that to make those grooves around the side of the trash can. I'm going to group those together and see what we get. Yep, that's about what I want. But we need to get that to happen all the way around the trash can. And fortunately, I know an easy way to do that. First though, we need to ungroup these things and switch back to the home view. What we need is to have a pair of capsule-shaped cutters on opposite sides of the trash can. So duplicate the existing one and flip it horizontally with the flip tool. Now we're going to move that flipped one over to the other side. Let's switch to a top view so we can see how this is lining up. We want to get these lined up pretty evenly. And so again, we're going to use the TLAR method. And that looks about right. So now we'll click away from this to deselect all of the selected items. And then we're going to select just the two capsule shapes. We'll click on one, hold down the Shift key, and click the other. And then we're going to group them together. So with these two cutters now acting as a single object, let's make sure that we're perfectly centered on the trash can body. So we'll select all of these bits and use the alignment tool and get it aligned. There, that looks about right. So next we're going to make use of a cool trick in Tinkercad to make more of these cutters and space them evenly around the trash can body. So click to select that cutter group and then click duplicate. And now we have two cutter groups and they're right on top of each other. So we're going to click on the angle setter here and we're going to set that to 20 degrees. And then we're going to click the duplicate button again. And this time not only did we get another set of cutters, they also rotated. So we'll keep on clicking that until we have cutters all the way around the trash can. And now we'll draw a selection around everything that's there and group it together. Let's see how that looks. There we go, that's the look I'm going for. It needs one more thing though. I want something to make the top look a little more finished. Now the trash can is 90 millimeters in diameter. So let's bring out a cylinder and set its footprint to 95 millimeters by 95 millimeters. And we'll make it 95 millimeters tall. We'll set its number of sides to 64. Then we'll set its bevel to 1 and leave its number of segments at 1. I'm going to move this over just a little bit. So now we've got this huge roller looking thing with a nice 45-degree bevel around the edge. But I really only want like the bottom, 10 millimeters of it, maybe 20 millimeters. So let's drag out a hole type box. And we'll set its footprint to 100 millimeters by 100 millimeters. And we'll set its height to 75 millimeters. Then we'll select both that box and that cylinder, and we'll use the Align tool and align them at the tops and align them on their centers. And then we can group them together, and that leaves me with this little bit here. Then we'll select both of these objects and use the Align tool again. We'll align them on their centers and at the top. Then we're going to switch to the front view. So now we'll select just that new part that we made, and we'll use the Z handle to move it up a little bit. Maybe a little bit more. TLAR again. That looks about right. And now we can select both of those objects and group them together. And woohoo! We have successfully designed a trash can for Vase Mode printing. Let's export that as an STL, and then we can slice it and print it. Okay, so here we are in Prusa Slicer. Let's drag that trash can STL file in. There it is. Now I'll be printing this on my Creality Ender 3 Pro. I've got it connected to a Raspberry Pi running Octoprint, and I've told Prusa Slicer how to connect to it. It's very easy, and if you want, I'll make a video about that. Just let me know in the comments. This makes it extra handy because you can print right from Prusa Slicer to Octoprint. Anyway, I'll be printing this using my spool of Alien Ooze PLA. I haven't printed much with it yet, but I wanted to see how it looked as a single wall print. and I'll print it at 40 millimeters per second. Now, we'll want to turn on Vase Mode, otherwise this print is going to end in sadness and failure. And what I mean by that is the model is solid, so we'd use a whole bunch of filament, and in the end, we'd have a trash can that was, well, solid. We wouldn't be able to use it for its intended purpose. So here's where we go to enable that feature. Click on the Print Settings tab. And right here in the vertical shells part, click the checkbox for Spiral Vase. And when you do that, you'll get a dialog box telling you about all the other settings that Spiral Vase Mode depends on. And Prusa Slicer will adjust them all for you when you click Yes. So, click Yes. There, now we're all set up to print the trash can in Spiral Vase Mode. But there's one more thing that I want to adjust, and that's the extrusion multiplier. See, this print only has a single perimeter, and with a 0.4 millimeter nozzle, that means the thickness of the sides of the trash can will only be about half a millimeter thick. I want it to be a little bit thicker, but I don't have a larger diameter nozzle installed on the printer. But what I can do is increase the extrusion multiplier and get a little bit of extra filament squeezed out as we print. And that should give me a slightly thicker and therefore stronger sidewall on the trash can. So let's drop into the Filament Settings tab. And right here in the Filament section, it is the third item. Right now it's set to 1, and I want to set this to 1.25. Okay, now let's click back to the Plater tab. Then click the Slice Now button. The preview shows what the model should look like when it prints. Now you can export your G-code and send it to your printer. And because I've got Prusa Slicer set to send directly to Octoprint, I can click the Send G-code button and send the file over. I can even have it start printing as soon as it receives the file. I'm going to do that. Now we'll let it run, and in about 2 hours, we should have a trash can. So here we go. Now we've got our desktop trash can. And when you look at a model this size, if we had designed it as a hollow model, something that had walls maybe a millimeter thick, it would have taken a lot longer to print. But because we're only printing one perimeter, the outer contour of the model, it prints a lot faster. Now because it is only one perimeter thick, it's got some give to it, but that's okay. I wasn't expecting a rigid trash can. So this is printed in Alien 3D's Alien Ooze PLA. What do you think of it? I think it's cool. To me, it looks like green glass. You can buy this filament on Alien 3D site, and I'll put a link in the description. Okay, so that's our Tinkercad design and print for today. We learned how to design a trash can. We learned about the TLAR method. That looks about right. And we learned about printing in Spiral Vase Mode, which is kind of a cool thing because Vase Mode prints finish quickly. Okay, thanks for making it all the way to the end, and thanks to everybody who likes, comments on, and shares these videos. And if you haven't subscribed yet, don't forget to do that and click the bell so you don't miss any cool 3D printing videos. If you liked the video, please give it a thumbs up. If not, give it a thumbs down, but either way, share your thoughts in the comments. If you like the content that I'm producing and want to help out, consider supporting the channel with a one-time micropayment. You could buy me a coffee or leave a little something in the PayPal tip jar, and links for those are in the description. Another way to help out is to make use of the affiliate links in the description when you are shopping online. It doesn't cost you anything extra, but a tiny portion of any purchase you make goes to the channel and helps cover the cost of making cool videos for you. Well, now that I've got a trash can model that prints well in Vase Mode, I'm going to go print a few more. You go print something cool, and I'll see you next time.